Welcome to my IPv4 series of videos and episodes where we'll be going through a complete, thorough and really important aspect of IT networking. This course is designed with Cisco in mind, but you can use it like for if you're studying for Net Plus or if you're just learning it IPv4 at the very beginning. We'll be starting at IPv4. The actual address structure. We'll be moving on to unicast, broadcast, and multicast. Then the third episode should be about the type of IPv4 addresses, then network segmentation. Finally, we'll finish it off with the subnet for an IPv4 network, which is the most challenging but the most exciting part of all this. So let's jump into it straight away. Jump over to my whiteboard over here. It's blank at the moment. So we're going to start off absolutely like right from the beginning. So I'm just going to see if my little pen's working here. Looks good. Okay, so let's start, and my writing skills is not the best, but this is where we're going to start in this episode. Now these episodes should not last more than 20 minutes, so you can look through it. Yeah, that's what we're going to work at. IP address structure. All right. So we are going to describe, and this kind of matches up with the CCNA Part 1 or the first version. There's 3 parts in the CCNA course, but again, this is absolutely you can use this content if you're studying for your A+, your Network Plus. That's the big one. This is where this is going to be used a lot. But CCNA is very important to learn this. In the old days, when the CCNA kind of first came out, this was very heavily in the exam. So if anyone's doing the CCNA exam, this was a big one. But not so much these days. There's 2 or 3 questions, or maybe a little bit more, but actually not that much. But still a critical concept to learn. There's calculators out there. You can get this information, you can do subnet calculations and understand really quickly. But if you're in a bit of a tight spot and you can't get the access to a calculator, or can't understand the concept, then understanding. Sorry. If you don't have access to the internet or the calculator, then this is going to be quite challenging. So if you understand the concepts of it, then you don't need the calculator. You can just do it. I mean, some people actually can do this in their heads, but we're not expecting that much from students right now. It's just something that takes years and years to develop. So describe the structure. The structure. Hard to talk and write at the same time. Describe the structure of an IPv4 address, including the network portion, right, and the subnet mask. All right, so this is what we're going to do now, and we'll start it off now. So let's have a look at the basic structure of an IP address, as we promised earlier. Now, I've color-coded this for a particular reason, and the first reason is I want to show you in a normal, everyday IP address, just a usual, conventional IP address that you might be using at home, like in your home router. This is something that would look pretty common. I mean, this section here would be like a 1 or a 2 or a 0. Most of the times it'll be 0 or a 1, and if you get a router from Telstra or Optus, or it'll already be configured on their machines already. This is a nice and simple, very common IP address, which we'll talk a bit about later. Why is it 192.168 when we're talking about the type of IP addresses? But for now, this is the most common, or this is a very common IP address that we're going to use. The red is our network portion, okay, and the blue is our host portion. What does that actually mean? Now, you might already be really aware of this and how this works, but we're going to go through it anyway. So I'm going to set up a little network here. That's a switch. A switch. This could be a switch that you bought from JB Hi-Fi, or if you're somewhere else in the world, just do your normal electronics store. It can be $50, $30. I think that you can get them really cheap these days. Out of the box, when you open it and install it, it's going to start connecting to the other devices, so these other computers. Okay, maybe you've got a laptop over here. You might have another, and I do know that my drawing skills is terrible, but that's not why we're here. I'm not here to teach art. Thank God for that. But what we're saying here is this is a host. Okay, this is a host, and this is a host. Or we also use the words nodes, but I think hosts is is probably the most. I don't know. When I first trained, we used to say nodes all the time, but I guess host is. Either way, they're both used in the IT industry. You can swap them, no problems. So these are hosts. The switch is not a host. Okay, the switch at the moment, out of the box, when you open it and it's just switching, just doing layer 2 switching, it's not a host itself. Just ignore this part if you're still really new at this. But if you kind of know a little bit of networking, if I've got a Cisco switch and I assign like the default, say VLAN 1, I can assign an IP address to that VLAN, to the switch, then it does become a host technically. But for now, we're just going to look at the way that they're default, the way that they're configured. So now, what is this? What exactly are we looking at here? Okay. We are looking at a network. Can you see where we're going with this? This is a network. These are hosts. How does that sound so far? Consider that for a second, because in the end, we can go through all the complicated IP addressing, subnetting, and VLSM, very linked subnet masks, which we were going to go into. But at the end of the day, if you don't understand this concept, you cannot progress any further. We've got to understand this part here. It's critical. Okay. So this part here is a network. The network. Okay. This is a network. I will have maybe another link to a router. Maybe it's a wireless router, and this will go to the internet. That big fluffy white cloud. So let's delve into this further. So we have the network portion, and we have the host portion of this IP address here. So this over here is the network address. Network address. Just that first portion there. The second portion is a host address. Okay. So that host address I can give to this guy over here. The laptop over there, I need to give this laptop a different host address. It cannot be 10 because this is already taken. This one is 11, that's the host address. And over here, we have another host address, 12. Now, with the router, Okay, it's a little bit of an advanced topic, especially for beginners. The router, what a router does, okay, is it segments different networks. So if I want to leave this network, I need to go through the router. So on one side, on this network interface, that belongs to which network address? Well, we've only got one here, so this is a nice and easy one. So that will be, it'll belong to here. Okay. Now, I need to give this a host address. So that a router will have 1, 2, 3, 4, 5 different host address. They will have multiple. But on a, like, if we keep this simple, just for now, the host address is actually the interface here, -1. Usually we write the router as a .1, usually just best practice. You don't have to, but best practice, so that whenever you see a .1, you think, well, that should be our gateway address or our router address. That gateway address it'll be like a doorway or a portal or a gate that'll get us out of this network to somewhere else. Okay, so we've got the host addresses. That's nice. But how do the computers see themselves? Like this. And I'm mixing the colors around because apparently color coding things is actually very, very beneficial for us to, data retention, or sorry, memory retention. .10 and then .11 and 192.168.10.12. Okay, 192.168.10.1. Okay, so that's how they see themselves as the complete address. Okay, so next part. Let me just let me clear this board, and we'll start fresh. Start from the beginning. So I hope that you understood that concept, because it's really, really, really important. Like, I can't stress how critical that concept is. Understanding what's the network and what's the host, like in a physical topology. But we're going to go into this a little bit deeper. We're going to have a look at the actual structure of an IP address, the physical structure, sorry, the logical structure, the actual address itself. So if we get 192.168.10.10, actually, you know what I might do? Let's color code this. So, which one is the network portion and which one's the host? I'll give you 5 seconds to think about it. I won't pause. I'll actually wait for you for 5 seconds to consider this. Really important. I think 5 seconds is up, right? Let's do a line here. Okay. That's our network portion, and that's our host. I know that I'm oversimplifying this, and but it's so critical that you need. If you understand this, we can go to the next step quite easily. All right. So now let's have a look at this even deeper. Now, this is human readable. Okay. As humans, we can look at this number and understand it. And it makes sense to us, but this is not how computers communicate with each other. Computers communicate in little ones and zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now there are 4 octets. We call these octets. And there are 4 of them. Why do we call them octets? 1, 2, 3, 4, 5, 6, 7, 8. Oct is, I think it's 8 in Latin. And so octets, so that's 11. Sorry, I'm looking at the number there, 11. There are 8 bits. 8 bits. So what's a bit? A 0 or a 1? I don't know what happened to my screen now. I think I touched the drawing pad accidentally. Really strange. Anyway, so that's 8 bits. What's a byte? Yep, is 8 bits, 1 byte. So 1 byte is 8 bits, okay? But we're not talking about bytes, but just so that you're, if you're curious, 8 bits, okay? Octet. So for those who are not too bad at maths, let me finish this. Now, why this is 1, 1 and the zeros, we'll go through that. We'll get there. But let's continue the scheme here. This bit scheme. This one will be 0, 0, 0. This will be 0, 0, 0. And this one will be the same as that because they're both 10s. Running out of space here. Let me see if I can move this over a bit. Yep. Always happens to me. I always run out of space. Start off big and then, yeah. So we've got that now. So so for those who are not too bad at maths, we've got how many octets? 1, 2, 3, 4 octets. 4 times 8 equals 74. 45. How much is 4 times 8? I'm sorry, it's just my humor. 32. Okay? We have 32 bits. Okay? 32 bits. So, if I only count up to here, if I only do this, how many bits will I have? If I only have that, if I remove 8 bits from this address, how many will I have? 17? No. I think enough of those jokes. It's going to be 24 bits. Okay? There's a reason why I've done that, why I've mentioned that. Because when we're doing network masks, we are actually going to reduce, we're actually going to take some bits away when we're actually going into determining the hosts and networks. And let me give you an example of it now. So we know that our host is like that. Let me just divide that to make it a little bit as neat as and tidy as I possibly can get it. So now I know, because of our last diagram in the 5-10 minutes ago, I know that the first part is a network, okay, and the last part is host, okay? So how many bits are now, okay, how many bits are in the host? It's going to be 24. 24 bits. Now, put this in like your mental mind palace or like the little filing cabinet, or write it down and put it to the side. Because we've counted 24. We're not going to use this yet. This is called CIDR notation. Just put it on the side, write it down, and we're going to come back to this. But we're going to use this a lot, okay? A little bit later on down the track. But just be ready for it, because we've counted 24 bits, and that's slash, it's called slash notation or CIDR. But now, what we're going to do is for the host, okay, for the host, we are going to we're going to write these as ones. The ones that are continuous or contiguous, it's hard, means that they have to be contiguous. They have to be in a row. If I put a 0 there, then the network stops there. Even if I go all the rest ones, okay? Now, but in this demonstration, I'm going all the way. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So these are all the host bits. Network, my apologies, network. They're the network bits. Here, I'm going to put them all as zeros. 1, 2, 3, 4. Alright, can you see where we're going with this? Okay. So what this means is that when I'm switching for this, so this is going to be my subnet mask or network mask, whatever you like, whatever you want to call it. Subnet mask is probably the most common term, or network mask. So what this is saying is that if I make all these as ones, that's my host. That's my hosting address. Okay, and that's going to be this is going to be my network address, my network portion, and this is going to be my host. So this is host and this is network. Very easy to confuse the terminologies, so I'll just make sure. The host will always be zeros, always. If I turn this in, just for a later down the track, if I turn this into a 0, then the border gets pushed that way. That now becomes the host bits. What all this means, we will get there. We just got to build this bit by bit. Pardon the pun. Right, so remember, the subnet mask is used to determine the network and the host. Okay, we got that? Okay, beautiful. Let's continue. So now I'll show you a little bit about bit maths, if you like. It's called ANDing. Now, personally for me, it never really helped me learn the concept, but a lot of people swear by it. People like this explanation, okay? It's called ANDing. Okay. So what we need to do is to identify the network and host portions of an IPv4 address. The subnet mask is compared to the IPv4 bit by bit. Okay? So bit by bit, as in not little bits and pieces, like actual bits. So this is my subnet mask. I'm comparing this to that. And in order to do that, for me to do that, I need to add them together. Okay? Add them together. Okay? Now, here are the rules for ANDing. Alright, so here are the rules. When I get a 1 and I add it to a 1, okay? What do I get? When I add a 1 with a 1, what do I get? I get a 1. Okay, not 2, because we're looking at bits here. We're not looking at 0 to 9 numbers, which is called base 10. We're not working with that. We're working with zeros or ones. So a 1 plus 1 equals 1. A 1 plus 1 equals how much? A 1. Okay, with me so far? Now, a 0 plus a 1. Now this is strange. This makes absolutely no sense for now. Okay, for now it doesn't make sense, but it's going to make sense later on, especially when I turn this into a 0 over here. I'm going to turn this into a 0 and I'm going to redefine the border, the border between network and host. But stay with me, okay? Stay with me on this one. Zeros and ones, 0 plus 1 equals 1. Okay. And on and on and on and on and on. Okay? So in that case, they're all, anything that's got a 1, anything you add with that becomes a 1, the final answer. Again, it doesn't make sense logically, but there's a great reason for this later. Okay, so now, interesting times now, interesting. So that's the ones there. Okay, so that's our network portion. So what happens when we get zeros? When we bring 0 into the picture? 0 plus 0. Okay, you know, logically speaking, you'd say that's a 0, right? If that was your answer, if that was your guess, congratulations. So we've got 4 zeros there. 1, 2, 3, 4. We've got one more here, so there's a 0 there and a 0 there. But what about the 1? 1 plus 0. Shouldn't that be 1? Well, logic dictates that it should be a 1, but not in subnet masking. It's a 0. So it's 1, 2, 3, 4, 5, 6. There's 0 plus, I'm running out of space here, so 0 plus 0, and then a 0 and a 0. So, interesting, right? What is going on here? What's the purpose? Why is this happening? Okay. So we've got to try to make more space. I don't really want to get rid of this. I kind of like this. Put a lot of time and effort into that. We'll just go up a bit. So this is why we're doing this. We're going to have a look at what those ones mean. We're going to put them in placements. We're going to place them. And we're going to start over this side. Now I never get this right in terms of space. Now every single Cisco exam I've ever been to, and most Microsoft exams that I've done, this is the first thing I do when I go into the exam center. These days you can do the exams at home, which I've done a couple at home. They're really good. So in the little kind of like a Microsoft whiteboard inside on the computer, which you're allowed to use with the testing environment. This is what I do straight away, especially when I'm doing a CCNA exam. Okay. Sorry guys, my drawing is terrible. My art teacher in high school used to say to me, "You're very talented in everything, well, most things, but you're horrible at heart." So they kicked me out of the class. Not because I was misbehaving, it's just I was just terrible. So if we go back to this diagram here, this is 1 octet, okay? That's 1 octet. All right, so 1 octet. You'll notice all the ones here. So what I'm going to do here, first of all, I've got 3 lots of ones. I'm going to draw this really quickly. I'll pause the video and I'll draw this really quickly so you don't have to look through them all. Awesome, magic of live pause. Now I've just noticed, you probably noticed that I actually forgot the 16. Poor 16. I forgot all about that number, but I fixed that. So this is my first octet, second, third, and fourth. See how I've done that? I've put that in. Now, this is really simple, and I've oversimplified this, but doing this later on when you're doing subnetting is absolutely critical. You need to get in the habit of doing this. Okay? So now, what am I doing? Like, why am I actually going here? Because I'm going to add, which is another color. Let's choose purple, I think is good. I'm going to add these numbers together. I'm going to add 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. If I add the numbers together, I'm going to get 255. 255 255 dot 0. Does that look familiar, guys? What does that look like? Let's write it out properly. What does that look like? Has anyone seen this before? Dot 0. Let me show you my my personal networking. I'll just bring up my little my own networking. Where is it? There it is. Computer's a bit slow today. Go to network, change adapter settings, and so I brought up you can just over here. I usually have a little program called Zoom It. It's a pretty good one. Zoom. I've got two screens here, so I've got to see if I can zoom in here. There we go. Let me just bring this. Where is it? It's over here. Okay, let's zoom it. Excellent. So let's jump into properties. Double click protocols. Oh, okay. Details. You know what? I've got some virtual machines running, so I think they're taking over my IP addressing. Yeah, that's what's happening. All right, it's not a great example because not exactly what we're looking for, but you'll notice we've got a subnet mask here. I've got 255. Yep. Just having a bit of trouble with my Zoom It tool, but anyway, you can see the subnet mask there. 255.240. That's interesting. Why is that not 255? We're going to get back to that in another lesson completely. But in our scenario, if I was configuring a simple network, I would have that as the IP address. I'd put it 192.168.10.10.15, doesn't matter. Subnet mask here would be 255.255.255.0. So now that's familiar now. You've seen this. You've probably seen this many times before. And I don't know, this Zoom tool was working nicely for me, but anyway. So that's where we would configure that. So that's where you would probably think that looked familiar. And what that's saying is that anything that has that subnet mask, that means that the first 3 octets belongs to the network. Okay, critical, please. If you didn't understand, if I didn't explain it in a way that is easy for you to understand, please let me know. Send me a message in the comments, or if you can, for my students, if you can contact me directly, and I'll find another way of explaining it to you. It's a critical concept, and you need to understand this thoroughly. Now, it does get more complicated than this, but for simple, small home networks, this is sufficient and fine. Okay, so now let's keep moving up because maybe we have to clear this canvas. Yeah. Let's clear the canvas now. We can start from scratch. So there are different like many different types of network masks out there. I'll do a couple of them. I won't do them all because there's quite a few, but I'll give you some examples. So this one here, so that means that is network, and that is, what is it? Host. That's a lot of hosts there, by the way. That's quite a few, like millions. So that's the network portion. Okay, let me give you another example. So if I go, we'll keep this nice and simple. We won't do any subnetting or anything like that. We'll just keep this. No, we've already done that, haven't we? We do this. So where's the host? Where's the network? Fantastic. And we've already seen the usual one. There's a bit of a pattern here, by the way. Now, I'm just going to throw this out there. We're going to do another valid IP network mask, which we haven't covered yet. You saw mine actually, my personal device. .0, and you're thinking, what? Where'd you get 240 from? And there's another lesson that we're going to cover. We're going to cover this. Basically, if you're curious right now, it just means that if the normal way we do subnets masks, say I've got 500 devices. So you know what? Let's say this. I've got 300 hosts, and my subnet is not enough to cover that. But I don't want to have tens of thousands of IP addresses. I just need 400. I just need 400. We'll be doing these exercises later on, but then we're going to do some subnetting in that scenario, and we'll use a network mask that looks like this. So remember, I talked about slash notation. I'm not going to talk too much about it right now. We were going to talk about it later, but that's a /8. And why? Because I'm only using the first octet. 1, 2, 3, 4, 5, 6, 7, 8. /8. This one will be a slash. 8 plus 8 is how much? 16. Now this one, because I'm borrowing some bits here, and I know it's I know we haven't covered anything at all, but just for your reference, that's going to be a /28, because this one here, so we've got 16, sorry, we've got 8 plus 8. This one has 8 as well, but we're actually going to steal. We're going to be criminals here. We're going to steal from the host subnets. Like, what? You can do that? Yes, we can. And we're going to steal 1, 2, 3, 4 bits. The last 4 bits are going to be host. Okay? So 8 plus 8 is 16. 16 plus 8 is 24. 24 plus 4 is 28. Okay? So we're getting the basics underneath. We're not experts yet. We're building this narrative here. We're building this storyline. Okay. So next concept. And I know this lesson looks like it's going a bit long. Looks like we're up to I think about 45 minutes. I don't want to break these up too much. So we'll keep going, I think. Might be the way to go, that we just got to keep going. All right, so the next part that we're going to look at. So the next part we're going to look at is, we'll talk about the network and host, which we already have, but we'll go into a little bit more. We're going to talk about the host and the broadcast address, and we're going to talk about the first usable host and the last usable host as well. Let's build up a physical topology. So a physical topology is actually like real computers that we're going to use. Well, not real computers, but you know what I mean. We've got a switch here. And we're connecting to each other. We're going to give this, so this is going to be a network address, okay? Of 192.168.10.10. Or is it? That's the IP address for that. But that's a host address. Why am I doing that? Well, that's not, I'm doing the wrong thing there. I'm not doing the correct thing. I have to put a 0 there. That becomes the, well, that's the network address. So that means that PC, that node or host, and that host is a part of that network address. For example, if I send a little message to that address, or if I send some sort of networking, they're all going to get it. It's like going to your street, and your street might be Smith Street. If I don't put the number in front of Smith Street, well, I mean, it's not really going to happen in real life, but that's like sending a letter to everyone in the whole street. Okay, so that's Smith Street, for example. Not a really good example, but hopefully you understand what I'm trying to say there. So that's the network address. Remember, these have their own unique host address. Oops. .1, and because 192.168.10.2. Okay, that's that address here. That's the network address. This is really important. Please pay attention to the 0 here, because that 0 I can never, well, all right, bear with me on this one. I'm going to say you can never use that. Okay, but you can. We'll talk about that later on. I don't want to say, but you told me this and that. But for now, you can't use that as an address, as a valid address. Okay. Because that's the. Why can't we use that address? Because that's the network address or subnet address. If you like, a little later on, we're going to be doing subnetting. So I can't use this because this defines the network itself address. It's not usable. I can't use it. It's already taken. The address, the subnet address or the network address has taken it. It's unavailable. Okay? All right, so let me just clear this a bit. Actually, I probably should have just used the eraser. So we've defined that, okay? Fantastic. So where can we start? What can I give these addresses? Okay. I can start at .1, 10.1, so I'm just being lazy here, 10.0, 10.1, 10.2. So because they're in this network and they've got a subnet address 255.255.255.0, that means only this is network and only this portion is host. I cannot, in this network, I cannot use something like this, for example. .11.5, for example. That will mean that's outside of this network. It's somewhere else. I cannot use this. I can only use them with 10. I can only use that begins 10 on the third octet there. But how far can I go? How far can I go? And this is where we're going to the next part here. Let me just move this up here. How can I calculate? How can I find out how far I can go up to. Okay. In order for me to do that, I'm going to get my good old my bit placements, as I like to call them. I won't forget 16 this time. 32, 64, 128. Put these lines here. Okay. Okay. Because why am I doing this? For my first host, okay, the very first one. What's the last? Let me just, maybe if I scroll back down a bit. What's number one? What's the bit version of number one? Okay, it's a 1 there, and the rest are going to be 0 because the value of this one here is 1. Okay. What about number 2? What about the second host on the network, the second one? Well, there's a 2 here. That's number 2. So I'll put a 1 there, and I'll put a 0 everywhere else. With me? What about 3, however? There is no 3 in this placement, right? So I'm going to add 1 and 2. Okay? So on and so on and so on until I get to the I'll get to the second last one. So the second last one will be let me check, it will be like this. So I'm going to keep doing that until I get to the second last number. This is the second last one. This will equal 254. This is the second last number. If I fill if I fill this, if I fill them all out, that equals 255. Okay, so I've got 0 up here, and then I've got 1, and I have 2, 3, so on, until I get to 254. Sorry, I think my head's in the way. Let me put that up a bit. Yeah, my big fat head. So I've got 1, 2, 3, all the way to 254 and 255. Okay? So I start at 0 and I end at 255. There are two, well technically, okay? If I count the 0 as an address, there are 256 addresses. Okay? I've already said that we can't use the 0 because the network is using it. It's taken. 255 is also taken. I can't take it now. I cannot use that. It's not usable. And I'll tell you why in a second. The usable addresses, any address from 1 down to 254. So, if I have 254 hosts on a network, I can use them all. If I have 255 hosts, I'm sorry, I can't use it. I need another scheme. I need an addressing scheme that's bigger than this. But if I have 254 and under, then this is going to be more than sufficient. Okay, so I hope that's made sense there. So now, the last thing we'll go through now is why can't we use 255? Now let me get you some examples here. So it's always good to write this out. 192.168.10.0. Okay, that one is our network address. Okay, the second one, 192.168.10.1 is usable. We've got a green light here. Then there's the second usable, and we'll go all the way down to 254. If I wrote all this down, it'll be be wasting time. 192.168. This one here, we can't use it because it's a broadcast address. So, my head's in the way again. It's a broadcast address. So, what's a broadcast address? Okay, let's go back down and hopefully my diagram's still here. Okay. Sometimes in the networking world, sometimes I need, so if I've got another computer out here, so I wanted a different color. Say for example, I've got many computers. Now this computer here doesn't specifically know, doesn't know exactly where to send something. Doesn't know exactly where to go. Okay? It's sort of like saying, look, I don't need any help. I don't know where to go. Can someone help me here? All right? For a good example is if I don't know an IP address of if I don't know, if I'm sending a message to the internet, and I don't know where the gateway is, for example, I just don't know, the computer doesn't know how to direct the traffic out. It's going to say help. It's going to send messages to the whole subnet. Any IP address within that IP address, it's going to send it. It's going to send a let me just get some space here. It's going to send a broadcast message. It's going to say, "Hey, you guys, everyone out there." It's like radio, for example. If you're driving a car and you're listening to the sports or to music or to whatever that you listen to on the radio, you're receiving a broadcast. It means that when you switch it on, you're going to be getting it, whether you want it or not. I mean, you can switch it off if you wanted to, but in this scenario here, I'm going to send a message to this IP address. 10.255. If I send it to this broadcast address, everyone in the network will receive it. Okay, so that's a broadcast address, and that's why, if I go back here, that's why I can't use it. It's reserved. It's reserved for the IP address that receives all the broadcast. The network address, and these are the usable. Okay, so this lesson went on a little bit longer than I thought. It's basically what we covered, a bit of the network and network portions and subnets. We've had a look into the network address, the usable. Looked a bit about calculating calculating, seeing what the network mask is. And the next lesson, the next episode, we'll be talking a little bit more about the broadcast as well. Unicast, we'll talk about the one-to-one, and then the multicast, which are really interesting subjects. That should be a little bit shorter. But in the meantime, thank you very much for watching. If anyone has any questions, please send me a message in the comments or contact me personally if you're one of my students. I'd be more than obliged. If anyone needs anything explained in a different way, let me know, and we can go and do that in a different way. All right, thanks everyone for watching, and we'll speak to you shortly.